All right, next we're going to use some given properties. Log base 2 of 3 is 1.585, log base 2 of 5 is 2.322, and log base 2 of 7 is 2.807 in order to find some logarithms of other terms. So we'll be trying to think of what properties we can apply to simplify our expressions here. So we're going to be trying to write things back in terms of logs of 3s, logs of 5s, and logs of 7s. Okay, so let's take a look. We're going to look at log base 2 of 9. Okay, so we can relate 9 to 357 by saying, well, 9 is 3 squared. So this is equal to the log base 2 of 3 squared. And from our third logarithm property, that 2 up in the power can be pulled down in front outside so that this is just equal to 2 times the log base 2 of 3. So this is 2 times 1.585. Great. Okay. If we have the log base 2 of 10, well, let's see. 10 we can write as a product. The sort of pieces we have are log base 2 of 5, 7, 3. We know some others, right? We know log base 2 of 2. So we can think of this inside as a product. This is the log base 2 of 2 times 5. And our logarithm rule says that that's equal to a sum, the log base 2 of 2 plus the log base 2 of 5. The log base 2 of 2, that one is nice and easy, it's 1. And the log base 2 of 5 is on our list here, it's 2.322. And so this is equal to 3.322. Okay. So next up, let's take a look at the log base 2 of 7 over square root of 5. So that was 3.17. Okay, so this is a quotient. So we can use our second logarithm property to pull this apart as the log base 2 of 7 minus the log base 2 of square root of 5. Log base 2 of 7 is on our list. That's 2.807. Log base 2 of square root of 5 is not, but it's related to this base of, it's related to 5. We can express that square root as a 1/2 power. And so this is 2.807. Using property 3, that power inside that we're not sure how to deal with, you just pull it out front as minus 1/2 log base 2 of 5. So we can take coefficients from outside and pull them up into the power, or if we don't like having them in the power, we can push them down in front as a coefficient. Okay. And so this gives us 2.807 minus 1/2 times 2.322. So this is 2.807 minus 1.161. All right, and so we get 1.646. Great. All right. Just a couple more. For this next problem, we're going to write this as just a single logarithm. Before we can combine these terms, remember that our coefficients of the logarithms have to be the same. So here we have 2 log of 3x plus log base 3 of x minus 8. We're going to rewrite this as the log base 3 of x squared plus the log base 3 of x minus 8. Now that we have coefficient of 1 in front of both of them, we can combine them into a single term, a product. So this gives us log base 3 of x squared times x minus 8. Great. Okay. And then next, we're going to expand this logarithm. It's written as a division. As much as we can, we want to expand this, but we don't want to break any rules. Okay, so the things that we can do, if you have a product inside of a logarithm, you can pull it apart into sums of logarithms. If you have a quotient inside of a logarithm, you can pull it apart to be a difference of logarithms. And if we have a power inside of a logarithm, we can take the power out front as a coefficient. But logarithms are super duper useful for helping us to process kind of complicated expressions that have products and quotients in them. So for example, here, this has a quotient. So this is equal to the log base 10 of x to the 13th, y to the 4th, minus the log base 10 of a to the 5th plus b cubed. Now this second term is a sum, so we can't do anything with it. The only thing that we can simplify are products and quotients and powers, but this is not a shared power. A is raised to the 5th power, B is raised to the 3rd power, even if they were the same numbers, because it's not a single power, there's nothing we can do with the term. The first logarithm, though, log base 10 of x to the 13th times y to the 4th, this is a product, so we can expand it as a sum. This is log base 10 of x to the 13th plus log base 10 of y to the 4th minus the log base 10 of a to the 5th plus b cubed. And now we have x to the 13th and y to the 4th. It's just a single power inside of our logarithm. The power can go out front as a coefficient. And so we get 13 log base 10 of x plus 4 log base 10 of y minus the log base 10 of a to the 5th plus b cubed. Cool. Great. And so we see that although we have a bunch of terms, many of these terms are nice, simple little things. All right. Just a quick word of caution before we take a look at changing bases. There aren't any rules for simplifying logs of sums, logs of differences, where the difference or sum are inside of the logarithm. We don't have any techniques for that. Quotients of logarithms. So here this is a log divided by log, and we don't have anything for simplifying products of logarithms, logarithm times a logarithm. Okay, all right. So next up, we're going to be thinking about what we can do in the case that we have different pieces.